Okay, so today's lesson is 4.3 triangle inequality. Will this stuff be on the quiz? Yes. And some of you came to my help session earlier today, so you were able to get kind of a little bit of an introduction to this. It's really simple, okay, as long as you understand that we're going to learn three conjectures today, okay, and all of those are kind of the basis to what you need to know. All right, so the first question I'm going to ask you today is, can you make a triangle using any three line segments? So I want you to kind of talk amongst yourself, shout out some answers, all right, and figure out, okay, I've had a different view from all my classes. Some say, yes, absolutely, I can use any three line segments. Some aren't sure. So what are you guys? Just talk about it. Okay, so I'm not sure what conclusion you guys came to. Like I said, there's been a mixed review of this. So on your notes, you'll have two different sets of three line segments. What I want you to do is I want you to take the next 5 minutes, all right, and I want you to try to construct triangles. Try to construct triangles with these three, which is your first example, and then try to construct a triangle with these three side lengths, all right? I'm giving you guys 5 minutes, so work on that. All right, guys, so that's been about 5 minutes. Let's go over what we've got. Okay, so listen, the only real way that I can construct this is to know a similar distance, okay, where these two lines are going to meet up. So how I'm going to start out here, I'm going to start out with a straight line, all right, whatever distance I want. Then I need to use my compass to measure the distance of the first line, okay? So I'm here, I'm going to measure this out. All right, I'm going to duplicate that line length down here. So now I have the endpoints of my triangle. Okay, what's left over here doesn't matter. It's out of the picture. Okay, this is the same as the first. Okay, so now what I have to do next is duplicate this second line. All right, so let's bring you down here. Extend it. Now, you would have noticed, okay, if you drew that length line anywhere, let's say I drew it up here, it would have never met with the second line. So I need to find where these two lines intersect. The only way to do that is by drawing arcs. Okay? So I've used my endpoint over here to get me the first length. I'm going to use my endpoint over here to get me the second length. So I've just created an arc in which it's the same distance, okay? So if I start from this endpoint, here, look, every single point on this line is the same distance, is the distance as the second line. So I'm going to meet where the two lines overlap. I'm going to do the same thing with the second one. So here, where the two lines overlap, because I've created 1,000 different points where I could put that line. But that point right there is the point where they can intersect. So your triangle either has to look exactly like mine, okay, or it could be flipped. You could have done the smaller segment on the right side and the longer segment on the left side, which would have given you a congruent triangle. It just would have been flipped over. So those are my only options. So hey, I used 3 line segments. I made a triangle. That worked. Okay, let's try the second one. Okay, and hopefully you guys have already come to your conclusion. So we need to draw a line again, my base point. I'm going to start at, let me flip this guy over. All right, I'm starting right here at this end point. I need to get the length of my first. All right, pretty close here. There we go. All right, so I'm going to get the length of my base angle here. All right, and that's my end point. All right, now I'm going to measure these two. Let's see here. So if I measured this one, if I duplicate this guy and bring him down, and let's start from the left side. Let's draw an arc right here. All right. I think you guys can see where this is going. Those arcs are never, ever, ever going to meet. Okay. Therefore, it is absolutely impossible for me to create a triangle with these 3 lengths. All right. I can take my line. I can start from this endpoint. And no matter where I put it, it's never going to be long enough to meet this line over here. Okay, so that kind of just totally debunks everything. No, I cannot make a triangle with with any 3 sides. I can't. It's impossible. Okay, so just as a real world example here, this drawbridge does not make a full triangle when it's raised. Why? Those 2 pieces meet at the ground, okay, but when I open them up, what's wrong? Why don't they come to a point? Okay, I hope some of you said they're just not long enough. Okay, and that's the case. That's the case with a lot of triangles. Okay, if the sides aren't long enough, I cannot create a triangle. Okay, so here, all right, we've got the triangle inequality conjecture here. All right, what I want you to do really quick, all right, do it in centimeters. I want you to measure the lengths of all 3 of these sides. Okay, quick, measure the lengths here, measure these 3 lengths, and measure these 3 lengths. So do it in centimeters. It'll be easier. Okay, so up here I already have listed all of our side lengths, all of our side lengths. So all these clearly make triangles. All right, so we're going to try to figure out, all right, what about these allows them to be triangles? What the triangle inequality conjecture tells us that the sum, so add up the lengths of any two sides. Okay, so if I'm adding up the length of any two sides of a triangle, those should be greater than the length of the third side. So let's do that with all of these. So let's pick 3.8 plus 3.6. Is that greater than 2.6? Yep. Okay, let's do 2.6 plus 3.6. Is that greater than 3.8? Yep. And finally, let's do 3.8 plus 2.6. Is that greater than 3.6? Yep, works for all three of those. Over here, 3.9 plus 2.5, is that greater than 1.7? Yes. 1.7 plus 2.5, is that greater than 3.9? It's close, but yeah, it is greater. All right, and next, 2.5 plus, no, sorry, I should have used 3.9 plus 1.7, is that greater than 2.5? Yes, works. All right, and finally, let's do all of these. So I've got 2.3 plus 1.5, is that greater than 3.5? Yes. All right, 2.3 plus 3.5, is that greater than 1.5? Yes. And finally, I've got 3.5 plus 1.5, is that greater than 2.3? Yes. Okay, so yeah, it works with all three of those. Okay, so that's the triangle inequality conjecture. Now, an extension of that, okay, an extension of that and something that will make our life a little bit easier tells us it is only possible to draw a triangle with three sides if the sum of the shortest sides, so that's a plural, so you could put a 2 there just not to confuse you, if the sum of the shortest two sides is greater than the longest side. Okay, so the only one that I really care about is the one that adds the two smaller ones, okay, and makes it bigger than the largest one. So this one is the one that matters, because if this one's true, all of them are true. Okay, so this makes our life a little bit easier, so we don't have to check all of them in order to see if they are true. Make sense? Okay. All right, so here we go. Let's do a couple examples. So take a minute using our conjecture that we just learned. All right, take a minute and try to figure out, is it possible to draw a triangle with the sides of the given length? Okay, so we only really care about the longest. So is 5 less than 3 plus 4? Yes or no? Yeah, it's true. So can I make a triangle? Yes. All right, let's do this one. Is 8 less than 1 plus 7? No, it's not less than 1.7. Okay, it's equal to 1 plus 7. Okay, so adding them together and getting the same exact number does not work. It does not say greater than or equal to. It just says greater than. So no, I cannot make a triangle that has those numbers. And the last one, is 9 less than 3 plus 5? No, it is not. Okay, false. So no, I cannot make a triangle. So the only way I can make a triangle, the only way, and know that the sides work, is if the other two shorter sides are greater than, when together, the longest side. Okay? Make sense? All right. Next. So, what do you guys think? Here's another question for you. How do the measures of the angles in the triangle relate to the lengths of the sides? Okay, so to make it a little bit clearer for you, if I had a triangle, so I have a triangle right here, does the length of the side have any relationship with the angle? So does the length of this side have any relationship with that? The length of this side have any relationship with that? What do you guys think? Yes or no? Okay, again, I've had mixed reviews with all my classes, so throw out your answers. Do you think that the length of the angle has any relationship with the length of the side? Okay, hopefully you guys came up with something, and we'll get to an answer soon, okay? Now, second question, how do the measures of the exterior angles relate to the angle of inside the triangle? So what do we know about the angles inside the triangle? What do I know about all these angles? They equal 180. So an exterior angle comes out here. So we're asking, what is the relationship between this angle right here and the inside of the triangle? Can anybody guess? Okay. All right. Well, we'll get you an answer in a second. It's just kind of making you think about it. So right here, all right, the side angle inequality conjecture tells us in a triangle, if one side is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So what that's saying, let's take this triangle right here. I'm going to make this 14 centimeters. I'm going to make this 12 centimeters. I'm going to make this 8 centimeters. Now, I'm going to name this A, B, and C. What this is saying is the angle that is opposite the longest side is greater than the next side. So this is greatest to least. So A is the largest angle, C is next, and B is the smallest. So yes, absolutely, length of side has to do with, all right, the sides of the angle, and vice versa. Okay, so let me give you some numbers of angles. So if I had an angle measuring 70, an angle measuring 60, the third angle would be 50. So if I had sides A, B, C, which side is the longest? The side that is opposite the biggest angle, so C. Okay, what's next? B. And what's last? A. All right, so we're going to do some examples on the next page. You guys take a minute and answer those. Arrange them in order from greatest to least. So you're going to have to find some missing angles for the first two. So go ahead. Okay, so for this one, you should have figured out that, so I've got 85 here, so what's left? 95. All right, so what is the longest side? A. Next, B, because that's across from 60. And finally, C. all right, because that's across from 25. Over here, you would have figured out that this was 60, all right, so my longest was C, next was B, and last was A. All right, and the last one, they gave me sides, so I'm trying to figure out what angle is the largest. All right, so the largest side is 4, so the largest angle is C. Next, 3, which gives me B, and finally A, which came from 2. Okay, so pretty straightforward. So yes, they have to do with each other. Okay, so they feed off each other. All right, next. All right, so it's really, really important that we know the names, okay, and the terminology associated with the angles of a triangle when dealing with exterior angles. Of course, the exterior angle is on the outside. Adjacent interior, adjacent means next to. We saw that a little bit in chapter 1, okay, and we'll deal with it a lot in the future. So adjacent interior means next to the exterior angle, but on the inside. And the remote interior angles are the angles that are opposite, so not touching the exterior angle. All right, so our triangle exterior angle conjecture tells us that the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So basically, I'm going to put a Z here for my proof in a second. Basically what I'm saying is that P is equal to X plus Y. Okay, that's the triangle exterior angle conjecture. Now, really pay attention to this. I'm going to do kind of like a little paragraph proof here. Really pay attention to this because you're going to have to do a 2-column proof explaining this, and what I write here is really going to help you. Okay, so what do I know about P and Z? What do I know about P and Z? They are a what? Linear pair. Okay, so P plus Z equals 180. Okay, and I know that because they are a linear pair. All right, next, what do I know about the interior angles of a triangle? Okay, I know that X, the angle X plus angle Y plus angle Z equal 180. Why do I know that? Triangle sum conjecture. Okay, so I know that angle P plus angle Z equals 180. I know that angle X plus angle Y plus angle Z equals 180. Now, I'm going to move the Z to the other side on both. So angle P equals 180 minus angle Z. Angle X plus angle Y equals 180 minus Z. All right, so right there, I've got something in common with these two. What did I do with both of these? I did subtraction, excuse me. So in order to get from here to here, I did subtraction. From here to here, I did subtraction. Now, I know that angle P equals 180 minus angle Z. I know that angle X plus angle Y equals 180 minus Z. Okay, who can remember what A equals B and B equals C, so A equals C? Who can remember what that is? Anybody? Anybody? You? No? Oh, man. Okay, that's the transitive property. So because of the transitive property, I can say that angle P equals angle X plus angle Y. Because all I'm doing is saying, hey, if this equals that, and this equals that, then this equals this. Okay, so that's how I come to that conclusion. All right. So what relationships do the exterior angles have with the remote interior angles? So they're the same. They add up to be the same. So right here, I know that this is 135. So what do I know X plus Y equals? 135. Over here, this is 135. So I know that 90 plus A equals 135. So I subtract the 90, and A gives me 45. Okay, so pretty straightforward, pretty simple stuff, all right? And there'll be examples like that on your homework. Now, for the rest of class today, you will be doing 4.3, page 218, odds, odds 1 through 11, 13, 14, 16, 17. 17, I want you to do it as a 2-column proof. And like I said, it's very, very similar to what I did 2 slides ago. So refer back to your notes on that one. All right, so that is due by the end of class. You should have about 30 minutes remaining. That's plenty of time. All my classes have gotten it done in that time, so you should be fine. You can work together on it. That's fine. All right, use Mr. Lawless. He will be able to help you. And like I said, if you guys need any refreshers on anything, I really urge you to watch the review that I did this morning. And if you need anything more, you need me to explain anything, please don't hesitate to either email me or text me on the Remind app. All right, bye.